one after another. So probably I introduce one new term for you. You know everything that units. So now it is clear to you that a big industry or a complete plant comprise of many units, right? A complete plan comprise of many units. Now the thing is that, like, you can give the examples like a nation, a country with many states, a state with many villages, districts, like that, a districts with many villages, like that. So a plant with many units. So now, what are the units? Because it is not that uh, a particular place a pump is there and you say so this is a unit. So what should be the units? A unit you can term a particular section, you can call as a unit, as an unit, while it should comprised of many unit operations. Is that clear? A complete plant composed of or consists of many units. A unit consists of many unit operations. So now we have to know the definition of unit operation. The biotechnology people may know the unit operations, but I don't think that microbiology it is explained in your class. So if so, it is very fine. Anyone know the unit operation? The term unit operation. How we can say? Unit operation is taking place. Then two or more unit operations. Then we can say this is the units, and more two or more units. So then we can say it's a plan. So unit operations, all operations are not unit operations. Again, so I have put this definition here. You can see the unit operation. Okay, previous slide. Unit operations, it is an operation where transformation of mass and energy takes place. Yes, Nancy, you give the example that bioreactor, that's true, but we have to know the definition. So I hope this definition you can remind any time of your life. As I told you the definition of continuous plant, continuous process. I hope you don't forget it. Should not forget it. Continuous process, what I told, it's a process where no
Okay.
momentary stoppages are there. No momentary stoppage. That means I consider mass and velocity. Okay. Momentum always there. So no momentary stoppages are there is the continuous process. Because that is, though we understand the fact, but it is sometimes become difficult to express. So here the unit operations also, it's very simple definition, but many times even the fourth year chemical engineering student I ask, not only here in the colleges like ours, even in the IITs I was there, so that our students also miss that definition. You know, unit operation, they understand the process, they give the examples, but definition is. So I hope now you should remember it's an operation where transformation of mass and energy takes place. Now, Nancy, your reactor, your example suit this definition. Now anyone can say it's a, if a dryer is there, so dryer is an unit operation. So unit operation is taking place in the dryer because in the dryer what happens? Mass transfer is taking place. So some mass is, or moisture is taking away, we are taking away from it. So mass and energy, transformation of mass energy takes place. Evaporation, yes, it's a unit operation is taking place. Heat exchanger, yes, unit operation is taking place. So you can give your own examples you are working with if you keep understand this definition. So unit operation is an operation where the mass and energy transformation of mass and energy takes place. So mass can transform from one form to another form, and even at the end mass can transform into energy itself. So taking care of the what? Einstein's E equal to mc square law. It is possible if anywhere mass is converted into energy, that is also an unit operation. And if the energy also transform into mass, so that is also an unit operation. So energy could transform from one form to another form, that is also a unit operation. Mass transform from one form to another form, so that is also a unit operation. Okay. Now, now thermodynamic system is different, as I will tell. So don't confuse with it. So just first you try to remember the unit definition of unit operation. I'll discuss your points over. Okay. Now, biotechnology. So I hope you understand or get some outline of the. I hope you get the outline of the chemical engineering plants and the process. What I discussed, some outline. I will go details into some points also. I hope. And then in the, as I told you that biochemical engineering is the blending of bridging of the chemical engineering and biological behavior or biological process. So initially I discussed some features of the chemical industry and those the biological people could understand. And now how we look into the biotechnology. So biotechnology, how you can define, as its simplest, biotechnology is a technical technology based on biology. But but we chemical engineer, define the biological process in such a way that because we feel the biological process or biotechnology is evolved from the chemical engineering field, and this is true also. Okay, the oldest one is biological chemical engineering, engineering the technical field. Then biotechnology evolved from that after the involvement of the biological peoples. So, what we define that biotechnology as the ill treating field of chemical technology or chemical engineering. I hope the second point is clear to you. We chemical engineers define biotechnology as the ill treating field of chemical technology or chemical engineering. Ill treating field means the illness of chemical engineering or chemical industry, and then it could be treated by the people that is the biotechnology. Okay, the chemical engineers. This is called biotechnology as the ill-treating field of chemical technology and chemical. Where I told you that in the chemical industry, there are the field that is the effluent treatment section, effluent treatment unit. Okay, this is called ETP, effluent treatment plant. So where we have to directly take the help of the bioprocess. Why? We have to decrease the biological oxygen demand, increase the biological oxygen demands. We have to check the BOD and COD. After that, we have to select the specific bacteria to digest the specific waste coming out from the industry. If it is the oil industries are there, hydrocarbons will comes out from the refinery, and we have to find the suitable bacteria. We have to isolate the suitable bacteria from the nature, and if it is possible to mutate it in the laboratory, then we can use it to digest the hydrocarbon effluent coming out from the refinery. Okay, and if it is the fertilizer plant, again we can use some specific bacteria, microorganisms, and there are some ponds where the trickling filters or the ponds where the bacteria can culture by adding some nutrients, because I will tell you later in the next class also the difference in the chemical reactor and bioreactors in details. So the ponds where the bacteria, we have to allow this some time, more time for the for digestion, because the difference is that biological process take more time than the chemical process. We can burn something, we can create it, we can destroy by some other chemicals, but that chemicals again become the contaminant of that. So only bacteria can could digest or break the material into the some fractions and without further contaminations. But obviously, before discharging, we have to take care of that whether that bacteria we cultured or use for destroying that materials are hazardous, pathogenic or not. So if so, then again we have to separate that bacteria, and we also understand that that cell mass is also useful. So even you just understand from the chemical effluent, we are not discharging, we are taking the help of bioprocess, and that cell we culture, and that cell mass we separated after this destruction, and that cell mass can produce the protein that can further produce the high performance fertilizer and the amino acids, or that amino acids or protein could use for other purposes. So the question of profitability are there. You know, if someone asks you that using this bioprocess, what you gain? Yes, we again earn some money. Okay, so these are the techniques. Next, so I have discussed this part. Again, the biochemical engineering, how we define separately, we define the chemical engineering, biotechnology, now biochemical engineering. In the biochemical engineering profession, there are various bioprocesses actively involved in the synthesis and production of biological products. So, we have to imagine or scale up our mind from the batch process to the continuous process, because there are some drawbacks in the batch process from the point of the viewpoint of the engineering, uh, from the economic point of view, and so we always chemical engineer always prefer the process to exploit as the continuous process. So we have to think that the biological process, how we can make it a continuous process. Yes, the immobilized cell reactors, you can think, and where you can convert this batch process to the continuous process. But obviously, it is clear that the biological process, rate of the biological reaction is comparatively slow than chemical reaction. So in the next step, we have to find out that challenge, and we have to come out with some solutions. So today, so again, this part for your discussion, while I provide you this PowerPoint, so you can see biochemical engineering is continuing to deal with the design cost. So because this is the role of the biochemical engineer, what is, because many times we don't find what role I have to play as a expert in the industry. So here you can see the area of the biochemical engineers or biotechnologists, the design, construction, advancement of the unit process that involve the biological organism and organic molecules. So I hope you can write in and its applications. So, and the area of applications, that there are a wide area. So, including the pharmaceutical, biotechnology, and medical sector. Okay, and food sector. So everywhere, we can use our knowledge. So again, the chemical industry in the eyes of biochemical engineer. So I have discussed many things, but the terminology will be different, and some new terms are it is chemical engineers should know that are very much familiar with you. Here you can see whatever we tell the feedstock, preparation, and raw materials. So here the biochemical engineers generally see like that it is the livestock of resources, preparation of feedstock through sterilization, bioreaction using the living microorganism, separation using the cell membrane, or bio-friendly process. Other new term already introduced. I told you that. I hope you know it. Substrate concentration, product concentration, cell populations. You are very much habituated with that, but unlike the chemical engineer, biomass, biodiesel, because it's not that you only can contribute in the field of production and the fermentation only. You have a greater role in almost every sector where chemical engineers are contributing. So that's why you have to synchronize your mind with the chemical engineer. Most of the field, the chemical engineers are contributing. You guys, those having the biotechnology background or microbiology or biological background, have the scope to contribute. Like you can see this slide here, biomass. So biodiesel production, biohydrogen production, biological hydrogen. You know that hydrogen. This is the energy sector. Also, you can have a greater role. And chemical engineering, not only the chemical engineering are involved in this type of research. The biological peoples along with the chemical engineer. I work in the biotechnology department of IIT Kharagpur, where I was the chemical engineer coming from the industry, and with the many people from microbiology and biotechnology, they work with me, and we formulate the process and biohydrogen production. We scale up a pilot plant, and if anyone you get the scope for higher study in IIT Kharagpur, you go there if this pilot plant is there, which is producing biological hydrogen. And all of you know that the importance of hydrogen. Hydrogen is very important chemical, is used not only in refinery, in fertilizer, and nowadays worldwide we recognize hydrogen as the future fuel. Your lifetime probably you can see, or otherwise in the future generation you can see the entire infrastructure replaced by the hydrogen. And hydrogen, if we are able to produce it biologically, that will be a great option. So I will be taking one class on this biohydrogen production strategy, so that you can get the projects, or you can involve, you can dream to work in for your higher studies. You will get the huge scope. And then fuel cell. Fuel cell, I don't know how much you are aware of this fuel cell. There are the chemical peoples or other electrical peoples are doing, but you have the huge scope for the fuel cell, and there are the a category which is called microbial fuel cell, where the biological peoples and biotechnology peoples are involved. Students are doing their projects and getting it's a burning topic, and you will get huge scope for the higher education. Biosensors, okay. So the other terms, the next point is very much habituated with you. So cell division, lag phase, growth phase, stationary phase, death phase. Nutrient, substrate inhibition, product inhibition, as I already discussed. Now, the first point I will discuss, and I will close this chapter today. So the afternoon session I will be discussing the change of strategy. Okay, to make bioprocess to be economic. I told you that most of the bioprocess, because of their low production rate, generally does not catch the attention of the economy. Either they are involved for the production of high value product, so that means you produce the low, small amount but having high value. Then the any biological process become economic. But uh, like the chemical process, if we want to make it economic, so there are some challenges. You can identify it: slow reaction rate, identification of constant, slow reaction rate, maintaining sterile environment, challenge in separation, disinfection, and biohazard. So these are the constraints of the biological process, and we have to think about the strategies to overcome these constraints. So the next session I will be talking about the strategies to overcome this constraint. But obviously, this at the last point of your lecture, I'll request you to note all these points, that is the constant you feel, and I want to listen it from you. what will be your thought, your idea from you to overcome these challenges. So I request you to please note the constant of biological process. The first constant is slow reaction rate, maintaining sterile environment and batch inoculation, challenge this in separation, disinfection and biohazard. Okay, so you note it, the constant, you note it. Okay, you note it and you think it, so that at 4 p.m. we will meet and we will be discussing these issues. Okay, so I hope whatever we discussed today is clear to everyone, guys. Okay, okay. So please try to understand and make the concept clear, so that it is not required to always remember. It will set in your mind. Okay, so the constant you understand, then next I will be. So anyway, any questions are there from your end? Anyone can ask any questions. Either you type in your chat box or can ask. Any question, guys?
Good morning, sir.
Yeah,
Yes, sir. I
yeah.
have a question. Sir,
Mm.
you talk about the unit operation, like where the transformation of mass and energy takes place. Now, in that case, you said about the evaporation or a dry, such kind of things are also unit operation. Then, how are you going to
Yeah.
differentiate that basic unit operation from those industrial unit operation? Like, because that is
No, no,
more
no.
complicated and you,
No, no, no,
sorry, what?
nothing. Okay, Nancy, listen. Nothing complicated. Try to think it in a very simple one. Simplest way. Evaporator is an equipment where unit operation takes place. I told you it's a operation. So many things is going on. Many operations are going on. Many processes are going on. So if you find the transformation of mass, so mass is changing from one form to another form, energy is changing from one form to another form, or mass to energy, energy to mass, then only you identify that process as unit operation. That operation as unit. Suppose I am giving you someone hammering some material and making it dust, grinding it. Okay, so that is unit operation. Is that clear? Someone, some dust material is carrying from one point to another point through a conveyor. That is unit operation continuously. But if you transport some material through truck, that is not unit operation, because no changes of mass, no changes of energy, nothing else. If you grind it, so you are creating the more surface. So a big material, make it smaller, so creating more surface. You know that while you make a dust of any material, it becomes reactive. So reactivity increases by creating the extra surface. So like that, I told you that separation, evaporation. Evaporation, what happened? Separation of takes place, separation. So by employing you are giving the heat, so that more vaporizing volatile material will comes out from the mixtures. So the mixtures are separating. It consuming when the mixtures are separating, it consumes some energy. So like that. That's why I'm telling, if I industrially same, why you come think that it is complicated or nothing complicated? Only involvement of more and more unit operation and more units. That's why we say it is, it seems from outside it is complicated. Think in our kitchen, what happened? We are cooking rice. So just think how many stages are there. In industry, it's a boiler, it's a reactor where heat is providing, a bigger way. Just scale up your mind. You just scale up your mind. Nothing complicated is there. I am giving you the basic understanding. Once you understand the basic things, then you have to scale up your mind. Instead of single, you just scale up your mind, imagination that hundreds. Okay, is that clear, Nancy?
Yes, sir. Sir, one
Oh,
more thing, sir. Like, if you are talking about such kind of unit operation where mass and energy, like there should be some transformation, so it is necessary that we need to conserve that. Like for such kind of operation it require a closed system, because in case of sewage treatment plant, that is a completely an open system, so even though there is a transformation, we cannot conserve that.
No, no, no. This is not the issue. Don't confuse with the issues. Conservation of issues are the technique what to do within a system. We are not considering it. System, I'm taking that there are different type of process or operations are going on. My role is to someone ask you to identify them whether this is unit operations or not. Okay. So your questions are the different issues, whether we conserve or not within a system. So the systems boundaries, that concepts are different. Okay. So what I discuss about is in a equipment, in an instrument, some changes are going on. So I have to identify that whether is unit operation is going on or not. Is that clear?
Oh, yes sir. Okay sir.
Okay. So your issues don't confuse with that. So your question is absolutely okay. I'm not denying your question. So that is the different issue. You understand? Whenever we discuss about the different systems, what closed system, open system, what exactly there, and what we have to do, how to maintain a closed system, how to maintain an open system, then your points will arise. Whether conservation of mass, conservation of energy, we have to maintain or not. But obviously, conservation of mass and energy, we need to maintain or we need to analyze. Until you do conservation of mass balance and energy balance, you will not be able to do the economic analysis. Or in engineering point of view, or term is called feasibility. I will discuss. I'm getting your questions. I will definitely make the points in any time of my lecture. Okay?